get them right. So we talked about the three different forms of quadratic, and we talked about what can I find from each one of them, right? Standard form, I can find what can I find from the standard form? From the standard form, what can I find? From the standard form. The y-intercept. From the factored form, what can I find? From the factored form, what can I find? The zero. From the vertex form, what can I find? The vertex. Good. Now, what if I have the factored form and I want to find the vertex? What do I do? So remind me, what can I find from the factored form? The zeros. So I can do that, right? Find the zeros. Now, if you're looking at a graph, right? Let me graph something for you. Let me show you. So I'm going to graph y equals x minus 1, x plus 5. Okay. What are the zeros from x minus 1, x plus 5? 1 and negative 5. So we can see them right here. So 1 and negative 5. What do we know about the quadratic function? What's special about the parabola? The shape of it. What's special about it? What's special about a symmetric? What's special about a parabola? So we have an axis of symmetry that is actually cutting it in half, right? So we know that a quadratic or a parabola, right, it's symmetrical. Okay, what does the word symmetrical mean? So they're equal from the middle, right? From the axis of symmetry. So if I draw my axis of symmetry here, I know that this side is similar and symmetrical to this side. Yes? Okay. The axis of symmetry passes through what point? What point does the axis of symmetry pass through? The vertex, right? And we know it's the x value of the vertex. You guys remember that? So, if I take any point on the graph and I measure the distance from that point to the axis of symmetry and from that point to the axis of symmetry, it's going to be the same distance, okay, on the x value. It's going to be the same distance. So, the axis of symmetry is in the middle, and it's going to be in the middle of the two zeros. Okay? Because the two zeros have the same y value, right? So the axis of symmetry is going to be in the middle between the two zeros. How can I find the middle of 2 points?
Divide them by 2.
Add them and divide by 2. Right? So in order for me to be able to know where the axis of symmetry is, I'm going to have to add the 1 plus the negative 5 and divide by 2. Let's try that. So if I add 1 plus negative 5 and divide by 2, what do I get? 1 plus negative 5 is negative 4. And if I divide that by 2, I'm going to get negative 2. So my axis of symmetry is passing through negative 2. Is it?
Yeah.
Yes, it is. And I know that the axis of symmetry is a portion of the vertex, yes? It's the x value of the vertex, isn't it? So I already found half of the vertex. Now my job is to find the other half, which is the y value. Okay? So, first, you're going to find the axis of symmetry from your zeros. Let's write that down. So, to find the vertex of a quadratic when it's in the factored form, so I'm looking for the vertex. of a quadratic that is in factored form. So first step, you're going to find the zeros. Then you're going to find the average between the two zeros. So you're going to add. So find the axis of symmetry. By adding the zeros and dividing by 2. What letter did we use for the axis of symmetry? X, which is what in the equation? In the vertex equation? H. Yeah. So this gives me the H part of the vertex. Now, to find the K, which is the optimal value, this is what I do. Can I have your attention for a second? So I know what the X value of the vertex is. If I plug in that X value in for X into my equation, I can find the Y. So let's take the previous example that we just did. So Y equals X minus 1, X plus 5. I found that the axis of symmetry was -2. You guys agree with that? So if I take that -2 and I plug it in for X, it's going to give me -9. Let's see. Was my vertex at -9? Was it? Yes. Right? If I actually press on this, right? If I go and put my mouse on it, it's going to be at -2 and -9. Okay? So after you find your axis of symmetry, you're going to plug it into your equation to find the optimal value. Okay? When you do that, this is what you're finding the K of the vertex. Don't learn how to go from factored form to vertex form right away. That's the only way that you're going to learn, so you're going to have to follow these things. Are you guys okay with this? Now let's look at how can I find a vertex if I have the standard form. have the y-intercept, but how is that going to help you? Do I know a way to go maybe from this to this? From standard to factored? What do I do to go from standard to factored? What's the process called? The other way. What's the factor? Right? So I want to factor what we just did on the quiz. When I factor, can I find the zeros? Can I find the axis of symmetry? Can I find the optimal value? Yes. So there's one extra process that I have to do, which is actually factor. So I have to factor the standard form, put it in the factored form, then you're going to do exactly the same steps as we're doing here. Okay? So if it's in standard form, the first step you're going to do is you're going to factor. Then you're going to follow the steps above. So now we figured out how to find the vertex from the factored form and from the standard form. If I want to find the vertex from the vertex form, what do I need to do? H and K, right? Stated. That's it. You're done. So it's H and K. And that's your vertex. Make sure you switch this. Switch the sign, right? And this one you keep the sign. So it all depends on what form it's in, then you're going to determine what steps to do. So, let's look at an example. What form is this in? Factor. What can I find from my factored right away? The zeros. What are the zeros? 2 and 8. So x equals 2, x equals 8. Remember, you set each one equal to 0. So if I'm going to set x minus 2 equal to 0, if you bring this over, it's going to be x equals to positive 2. And that's why it's opposite to what you see. If I'm going to set x minus 8 equal to 0, so x equals positive 8. How can I find the axis of symmetry then? Adding the zeros and dividing by 2. So if I add 2 plus 8, and then divide by 2. So that's 10 divided by 2, which is 5. So far I have the 2 zeros, and I have my axis of symmetry. How can I find the optimal value? I didn't hear you guys. Plug in the axis of symmetry for what letter? X. So if I plug in the axis of symmetry for x, I'm going to get this. Y equals to negative 3, 5 minus 2, 5 minus 8. So that's going to be negative 3 times 3 times negative 3, which is going to be 27. So do I know my vertex now? What's my vertex? 527. So this is asking you also for the vertex form. How do I write the vertex form? X minus h squared plus k. Let's fill in the values. What's the value of a? -3. The value of a in all three forms, you see it's ax squared plus bx plus c, ax minus h squared plus k, ax minus r, x minus s. The value of a is going to be the same between all three different forms. So if you know the value of a here, right, it's going to be the same as the value of a in the vertex form. So it's going to be -3. X, what's h? So x minus 5 squared plus 27. Done. That's the vertex form. Then I have to put it in standard form. Where do you want to go from? Do you want to go from the factored form or do you want to go from this vertex form? It actually doesn't matter where you go from. They're both, you're going to have to expand. I usually tell my students, go from the whatever is given to you because just in case you made a mistake here, so you don't carry the mistake. Okay? So I usually like to go from whatever is given to me. So in this case, from the factors form. It doesn't matter. Either way is correct. Okay? So with a factored form, you're going to have to FOIL. Collect like terms. And then multiply the -3 in. So what is your y-intercept? What is it? -40. So we're using everything we learned in this unit so far to put it all together. So right now, what I want you to do is I want you to look at this question, and then on a piece of paper, or if you want, there is a whiteboards here. Try to get as many sections filled out for this one. Okay?